Hello, 8th graders, and welcome to our next lesson within this unit. We are moving on to lesson 10.4, which is all about zero and negative exponents. So if you were with me this last Monday, so I'm recording this kind of a week ahead, so that was on the 14th here. I think maybe 13th. Let me double check my math here. So sorry, we met on Tuesday, so the 14th. Yep. So I was right. So on the 14th, when you should have joined your Zoom meeting, we watched two Brain Pop videos. They did explain both the zero and the negative exponent. So that's what we're going to be talking about here in this lesson. So one thing before we get too far ahead is something new that I'm going to be starting this week is a code word. So if you ever have any questions, and a lot of times I always ask, are you watching the lesson videos? So from now on, I will be asking, do you have the code word from that video? So at any point within this video, I could stop and say, hey, the code word is this, okay? So I could be in the first part of this lesson, or if I move into a second part, it might be in the second part. So watch out for your code word, because I could ask at any point. If you have the code word, I could just ask everyone and email it out as well. So make sure you're watching our videos. So let's go ahead with our objectives. First objective is I can evaluate expressions involving numbers with zero as an exponent, and I can evaluate expressions involving negative integer exponents. Okay. Skipping our warm-up. Question of the day, how can you evaluate a non-zero number with an exponent of zero? So basically they mean a non-zero number, so anything that has a base of something that's not zero. So maybe 2 for an instant, okay? And you have an exponent of 0. Oof, again, it's so hard to write with this. I'm going to try and fix this a little bit. And then how can you evaluate a non-zero number with a negative integer? So maybe you have a base of 2 again, but you have a negative 3 as an exponent. So how are you going to solve problems with a negative integer? Or a negative exponent as an integer? Okay. So here are our rules and our key ideas. So if I have a 0 exponent, anything to the power of 0 is 1. Okay, as long as it has a base that is non-zero. So for instance, in this case, it's 4 to the 0, which it just equals 1. Same thing if I had that 2 to the 0, that is also going to equal 1. Okay, but if for some reason I had 0 to the 0, okay, we're running into, again, this definition here of undefined, meaning I cannot define it. It doesn't exist, basically. Okay. Your negative exponents then for any integer n and any non-zero number a to the negative n is the reciprocal of a to the n. Remember that reciprocal means that you are flipping the fraction, because ultimately any number is a fraction. 2 is then going to be the same as 2 out of 1, okay? So your reciprocal means you flip these two numbers and then you would have 1/2, okay? So basically what happens is if you have a negative integer, you're just going to move it to the bottom and it becomes a positive integer. Since there is nothing on the top of my fraction here, I just assume that the fraction is going to be, or the numerator is going to be 1. And I just move that base with the exponent down to the bottom, and I change this exponent from a negative to a positive. Okay. So again, the trickiest part is realizing that your numerator, for the most part, is going to be 1 unless there's something above here. Okay, and you need to flip them. But again, if it's just a whole number or base number with the exponent, you just flip them. The 1 goes on top, your base then goes on the bottom, and your exponent changes to a positive integer. Okay. Let's go ahead then. So here's an example 1. So again, we are going to start with those negatives. Like I said, we move it to the bottom. So right now it looks to be that your base is 3. Remember, that means you have 3 out of 1. So I'm going to flip that, and then I'm going to have 1 out of 3. And instead of having the 1 out of 3, I'm going to put 1 out of 3, and it's to the 4th, okay, because I'm changing that exponent to a negative exponent. From there, it's typically best to write or figure out what is 3 to the 4th. So again, remember that's meaning you're taking 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 3 from there. I don't have my calculator with me. 3 from there would be 60, 81. So I would have 1 out of 81. Let me just double check with my phone here and make sure I got that one correct. Yep, okay. So I would leave it as 1 out of 81. All right. Now for this one, okay, what I have here is that I have a negative 8.5 to the negative fourth out of negative 8, or times negative 8.5 to the fourth. Remember, when I multiply things, okay, I'm adding their exponents. So really I have this base originally, so negative 8.5. And when I multiply these two, since they have the same base, I'm adding then the exponents. Well, a negative 4 plus a positive 4, they cancel each other out because they're the same distance away from the number on the number line. And so you meet right at the middle, which is 0. So this is going to be an expression where I have it to the power of 0. So a negative 8.5 to the 0, anything to the 0, and whether the base is negative or positive, it is going to be 1. Remember, the only time it is different is if you have, for some reason, a base of 0. Give me a second. I want to try and expand this page a little bit again. So, because it's really hard to see this last one here. All right, so this last one's really hard to see. I'm going to try and rewrite it here, but you have 2 to the 6 out of 2 to the 8th. So when we were talking about dividing your powers, if they have the same base, means that you subtract these powers. So really I'm going to have the base of 2, and I'd have 6 minus 8. Now, remembering your integer rule, 6 minus 8 means that you're going to have a negative number. So I would have then 2 to the negative 2. We never leave it as 2 to the negative 2. Every time you see a negative integer, you need to bring it back to the bottom of that, to that denominator, or to the bottom of that fraction. So you're going to have to use the reciprocal and bring it down there. So basically, because it's 2 as your base, it's going to be 2 out of 1. You flip it, so you're going to have 1/2. Let me move myself. And then instead of having a negative 2 as your exponent, you're going to change it to a positive 2. Again, we don't like to leave it like this, so you're going to figure out what is 2 to the second. 2 to the second is 4. So your answer is going to be 1/4. Okay. Again, at any point throughout the videos, if you're getting confused, feel free to go back and rewind. If you need to rethink through things, you can always email me with questions. Make sure that you have your code word for this. Otherwise, you can also email me. Like I said, you can text me whenever you have questions. Let's keep going ahead then. All right, so the next part is an on your own part. So I want you to take the time to go through and answer these questions. So pause this video. When you come back, I will have the answers for you, okay? If you're having a little hard time reading some of them, I hope they printed out okay for you, but if you can't see them on your sheet very well, just look here. They're pretty okay to read. Making sure that you understand if they're negative. So you can kind of tell that they're a negative exponent if they got a little bit more space between the base and the exponent. Okay, so go ahead, pause the video. I will show you the answers when you get back. Alrighty, welcome back. Here are your answers for these problems. So for number 1, you should have gotten 1/16 because I moved that 4 squared to the bottom. 4 squared is 16. For number 2, moving that negative 2 to the 5th to the bottom because it's a negative exponent. And then I just figured out what is negative 2 to the 5th, so 32. You can keep the negative at the bottom, or you can move it to the middle or the top, as long as you just have one negative on your fraction. When you have this one, so number 3, when you have a base of 6, and then when you multiply them, remember you're just adding the exponents, so negative 8 plus positive 8 gives you 0. 6 to the 0 is then just a 1. Okay. Number 4, you have to use your division, so you're taking 5 minus 6, which then gives you a negative 1 exponent. So all you have to do for this one is move that negative 3 to the bottom. Again, you can leave that negative with it, or you can move it to the middle here. So on. This one was a little tricky, and I kind of thought about it for a minute, because if this was a negative, since this is a negative exponent, typically we don't like to leave them as negative, so we could flip it to the top, but it still works to keep it down here because you use that multiplication rule where you just add your exponents, so 7 plus a negative 4, which is like saying 7 minus 4. So you get to the power of 3, figure out what 5 to the third is, and you have a 1 out of 125. Problem number 6, I did the top part first, so using your multiplication and adding your exponents. So 5 plus a negative 3 gives you 2. You have 2 on the bottom, so 4 to the squared divided by 4 squared is going to be, 2 minus 2, which is 0. So you have 4 to the 0, which equals 1. Basically, if you also know the operation of anything up 1 out of itself, so if you had 6 out of 6, okay, that's also going to be 1. So the same rule kind of applies here. Okay. Let's keep going now. All right, so our next example, we have a negative 5 to the x of 0. So tricky thing with these ones is you have to realize, where is this exponent going towards? In this case, this exponent is only for the x. Okay, I know it sounds weird because I'm saying exponent and then x, but this one only goes to the x value. So really it's going to be like saying I have negative 5 times whatever x to the 0 is. Now, no matter what x is, okay, for the most part, I'm going to assume that it's something positive or negative, and it's not 0, okay? So anything to the power of 0, though, equals 1. So really, I'm having negative 5 times 1. Well, negative 5 times 1, then, is just negative 5. Okay, easy enough. This one's really hard to see, but I've got 9y to the negative 3 out of y to the 5th. Now, again, these exponents are only being related to that variable, which is y. And so far, for the most part, all we've seen is your exponents being to a power of an actual base number. Same rules apply if they are variables. So in this case, this 9 can stay out because this 9 isn't really being divided by anything. It's really saying 9 divided by 1. 9 divided by 1 is 9. Okay, so I just use my same rules of y to the negative 3rd divided by y to the 5th. So I'm going to subtract my exponents. So I'd have negative 3 minus 5. Well, that gives me y to the negative 8. We don't ever leave exponents as negative when we find our final solution. So again, I'm going to bring this to the bottom. So because it's just a variable, all that goes to the bottom is the variable. This 9 is still going to stay as your numerator. So you're going to have 9 on the top, and then it's just going to turn into y with a positive 8 exponent on the bottom. Okay. All right, let's keep going. Again, pause if you need to. All right, so this next part is an on your own part, which is kind of a perfect time for me to pause this video because, again, I can only record up to about 15 minutes. So go ahead, take the time to fill out these examples, to show out your work. Please find me back in part 2. In part 2, then, we will finish off the rest of these notes, and I will go through these answers with you, okay? So again, please make sure you are watching part 2 of lesson 10.4, okay? I will see you back there once you have finished these answers, okay? See you in just a minute.